Hello everyone. So in this video we will be dealing with the implementation of NLP for a non-linearly separable data using Python. The objective of the experiment is to demonstrate the use of multi-layer perceptron to solve the XOR classification problem. So initially in the experiment, we will be defining a neural network architecture with a specified number of input, hidden and output unit. Then the network model is trained using backpropagation and gradient descent. The network learns to minimize a loss function which is calculated based on the predictions compared to the actual output. Then we will be plotting the loss over epochs to visualize the learning process and to ensure that the loss decreases over time, indicating that the model is learning from the training data. Then after training, it tests the training model by predicting the output for a specified data points. Overall, the code demonstrates the process of building, training, and evaluating a neural network for binary classification task. So in this experiment, we will be using this XOR truth table for the values of input and output. So here comes the coding part. Initially, we will be declaring all the required libraries packages. Import NumPy as NP is used for numerical computing. Pandas as PD is used for data manipulation. And IO refers to the input-output operations. And for plotting, we are gonna use matplotlib. Then we will be initializing the input x and y for the XOR gate. As we saw before, the XOR truth table values will be considered here for the x and y values, and the inputs are given as arrays. Then we will be declaring the number of input neurons, output neurons, and the hidden neurons. N underscore x denotes the number of input neurons, N underscore y denotes the number of output neurons, then N underscore h denotes the number of hidden neurons. So in input we will be having two neurons, in the output we will be having one neuron, and in the hidden layer we will be having two neurons. Then we will be declaring a n variable which stores the number of training samples. Then we will be initializing the learning rate as zero point 0.1, which controls the step size of the gradient descent algorithm during weight updates. Then we will be declaring random C to ensure reproducibility of random initializations of weight. W1 represents the weights connecting the input layer to the hidden layer, and W2 represents the weight connecting to the hidden layer to the output layer. Then we will be declaring a variable named losses which holds empty list. This is used to store the loss values during training. Then we will be defining a sigmoid function. This sigmoid is an activation function which helps the output to be between the range of 0 and 1. Then we will be defining a function in order to compute the forward propagation steps of neural network. This function calculates the activations A1 and A2 of the hidden and output layers using the sigmoid activation function which was declared before. Then we will be declaring a function for backpropagation which will compute the gradients of the loss function with respect to the weights using backpropagation. This function calculates the gradients dw1 and dw2 of the weights w1 and w2 by propagating the error backwards through the network. Then we will be declaring the number of training iterations. Here the number of training iterations would be 10,000. Then we will be declaring a for loop. So in the for loop, for each iteration, it performs forward propagation to compute the output and loss, then performs back propagation to compute gradients and update the weights using gradient descent. Then we will be plotting the loss values over epochs to visualize the training process. Then we will be moving to the prediction function. So this particular function takes the trained values W1 and W2 and predicts the output for the given input pattern. So this will be the plot over loss value and epochs. Finally, we will be printing all the predicted outputs. So initially, we will be testing the trained model by providing different input patterns, and then we will be printing their predicted output. So this is how the output looks like. So this is all about the coding. Applications of multi-layer perceptron. So the applications of MLP are diverse and they are used in various domains. Some of the domains are listed below. So they are used in pattern recognition. Multi-layer perceptrons are extensively used in pattern recognition tasks such as image classification, object detection, and speech recognition. They can learn complex patterns and features from the raw data. and they are also used in natural language processing. In NLP, MLPs are employed for tasks like sentimental analysis, text classification, named entity recognition, and mission translation. They can process textual data and learn representations that capture semantic meanings. And then they are used in medical diagnosis. So they play a crucial role in medical diagnosis tasks such as disease detection, medical image analysis, and patient outcome prediction. They can learn from medical data to assist doctors in diagnosing diseases and predicting patient outcomes. Then, marketing and customer analytics. So, in marketing and customer analytics, they are used for tasks like customer segmentation, marketing campaign optimization, etc. They can analyze customer data to improve marketing strategies and customer engagement. Then, in time series forecasting, they are used. Multi-layer perceptrons are employed in time series forecasting tasks such as weather prediction, energy demanding forecasting, and financial time series analysis. They can capture temporal dependencies and make predictions based on historical data. Then, last, in game playing. So, in game playing, they can be used for tasks like game strategy learning. They can learn to play games by analyzing game states and making decisions to achieve desired outcomes. So these are some of the application of MLP. Thank you.